Section 10.5, Inverses of Matrices. We're now going to look at writing a matrix equation. What we can do is write a linear system of equations as a matrix equation. What happens is we take our coefficients, a, b, c, d, and we can multiply them by x, y. Now we already know from matrix multiplication, and actually we will write this down here. So we get a, b, c, d multiplied by x, y. We already know from our matrix multiplication that if we were to multiply these matrices together, we would end up with a times x, which is ax, b times y, which is by, c times x, so cx, plus dy. That's exactly what we have here. And we know that those values must equal E and F. Thus, we have this matrix equation. ABCD times matrix XY equals matrix EF. This means that we can solve for the matrix XY. So if we have ABCD times XY equals EF, then we move matrix ABCD to the other side by finding its inverse. The way we undo matrix multiplication is to use the inverse matrix. And that's something we're going to be talking about for the bulk of this lesson. Let's first look at an example, though, of writing systems of equations as matrix equations. So you have systems of linear equations below, A and B. I want you to rewrite these systems as a matrix equation, where you have a matrix of numbers times your variables equals your solutions. Try this on your own first, and then resume the video when you're ready to check your solution. For this first example, I want to make sure that my equations are in standard form. Meaning I want them to all be written in terms of ax plus by equals our solution, or ax plus by plus cz equals the solution. This first example is already in standard form, so I can just automatically put it into a matrix equation. I get negative 3, 5, 1, negative 4 times the variables x, y equals 2, 1. Now let's look at example B. This one's a little trickier. It's not yet in standard form. To put in a standard form, I need to rewrite these so that I go x, y, and then z equals some constant. So for the top equation, I get negative x plus 3y plus 0z equals negative 2. For the second equation, I get 0x plus y minus z equals 1. And then for the final equation, I get negative 2x minus y plus z equals negative 3. For this bottom equation, if you ended up getting the opposite signs on all your numbers, so if you got 2x plus y minus z equals positive 3, that's all right too. They're the same exact equation. Now I can transform this into a matrix equation. I get my matrix of coefficients, negative 1, 0, 2, 3, 1, 1, 0, negative 1, negative 1. Multiply that by my matrix of variables, x, y, and z. And this equals my solution matrix, negative 2, 1, 3. That's how I write these systems of equations as matrix equations.